Yes, can you hear me?
Yes, sir.
Can we start? Good morning to all. Myself, Shoaib Pirzadeh, Assistant Professor, Department of Chemistry, Milia Arts, Science and Management Science College, Bid. So in the last period, we have started a new topic, that is a thermodynamics second. In this topic, we have seen that is why there is need for the second law. So various points in this bit we have seen why there is the need for the second law. After that, we have seen different statements of second law of thermodynamics. Different statements of the second law of thermodynamics. Then we have seen that is an introductory part of that is the Carnot cycle. That is what is Carnot cycle and how it that is work. So Carnot cycle work in, we have seen in the last period, that is a Carnot cycle work in 4 steps. What are these 4 steps? So these are isothermal expansion, adiabatic expansion, isothermal compression, and adiabatic compression. So these are the 4 steps I have shown by using a graph. So you remember that diagram, that is how Carnot cycle work. So Carnot cycle, what are the 4 steps of Carnot cycle? So first is that is a isothermal expansion. So it is denoted here. This is this curve 1 to 2, or it can be named as AB curve. This 1 to 2 or AB curve. Isothermal, that is the expansion. Second, adiabatic expansion. This 2 to 3, this curve. Later on we will explain that diagram when we are obtaining the total work done in Carnot cycle. 2 to 3, or it can be read as B and C, B to C. Then isothermal compression 3 to 4, or it can be C to D. And lastly, adiabatic, that is compression 4 to 1 or DA, curve DA. So we have to obtain here, that is work done, total work done in Carnot cycle. The question may be asked for 10 mass, that is obtain expression for total work done in, that is the Carnot cycle. Total work done in, that is Carnot cycle. So as we have seen, that is Carnot cycle work in 4 steps. So these are isothermal expansion, then adiabatic expansion, then isothermal compression, and adiabatic compression. Now we see one by one. That is, first is isothermal expansion. So and we have to obtain, that is work done in, that is the in each step. That is in each step we have to find out the work done. And if we take the addition of all these, that is 4 work done, that is we can get the total work done. So first we obtain the work done in isothermal expansion. Now for isothermal expansion, let T2, P1 and V1 be the temperature, pressure and volume respectively of the gas enclosed in a cylinder. That is, T2 is temperature, P1 is pressure, V1 is volume of a gas enclosed in a cylinder. Now cylinder is placed in the higher temperature T2. This cylinder is placed in the higher temperature T2. Now the gas expands. The gas expands, that is the gas enclosed in a cylinder, enclosed in a cylinder. Now cylinder is placed in the higher temperature T2. This cylinder is placed in the higher temperature T2. Now the gas expands. The gas expands expansion of gas takes place, and here volume increases. Volume increases from V1 to V2. So when expansion of gas takes place, its volume increases, and it increases from V1 to V2. That can be denoted by curve AB. Previous diagram, that is we have seen, that is this AB, or I have given the here number 1 to 2. See here, this is 1 to 2, or you read as this one is A and this 2 means B. So AB curve or 1 to curve, 1 to 2 curve, that is the isothermal, that is expansion. Now, if Q2 is heat absorbed, and W1 work done by it, then according to first law of thermodynamics, what is the equation for first law of thermodynamics? Can anybody tell me the equation for first law of thermodynamics? We have seen in the thermodynamic first, Q is equal to mathematical expression of thermodynamics. Mathematical expression for first law of thermodynamics. That is Q is equal
Q equals to delta
E plus W. Correct. Q is equal to delta E plus W. But instead of Q, you have taken here Q2. And instead of W, we have taken W1. But here Q2 is heat absorbed and W work done. Since here delta is 0, so what Q2 is equal to delta E plus W1. That is the first law equation. Now in this equation, put delta E is equal to 0. Delta E is equal to 0. Then what we get, that is Q2 is equal to W1. Since delta E is equal to 0 because it is isothermal process. So therefore W1 is equal to, because this Q2 is equal to W1, but W1 is equal to RT2 ln V2 upon V1. What is ln here? Ln means what? Ln, it is a form of log. लॉग की ही एक शक्ल है. ln को अगर log में कन्वर्ट करना है तो 2.303 से मल्टीप्लाई करना पड़ेगा आपको. We have seen in the thermodynamic first, that is to obtain the total work done in reversible and irreversible process. So W1 is equal to RT2 ln V2 divided by V1. But here W1 is equal to Q2. That is, so we can write therefore Q2 is equal to RT2 ln V2 upon V1. So this is equation number 1. That is, we have obtained, that is work done. Here work done equal to, that is the heat absorbed, because delta E is equal to 0. So this is Q2 is equal to RT2 ln V2 upon V1, where Q2 is heat absorbed, R is gas constant, T2 is the final temperature, V2 final volume, V1 initial volume. So this is the, that is work done in isothermal expansion, and we have to call, that is we read this equation as equation number 1. Remember that equation, because we have to obtain work done in each four step. So this is the work done in first step, that is the isothermal expansion. We have obtained the work done in isothermal expansion. Now next, second, what is the second? That is obtain the work done in, that is the adiabatic expansion. Now the second, that is adiabatic expansion. Here also we have to, that is calculate the total work done. Now the gas is at point B. The gas is at point B at temperature T2 and has volume V2 and pressure P2. That is point B means, remember this point, remember this 2, this is B point, and this is third 3 is, that is the, we called as C point, remember. So the gas is at B, is at temperature T2 and has volume V2 and pressure P2. The gas is expand from volume V2 to V3. Now in first, that is isothermal expansion, the gas expand from V1 to V2. Now here, that is gas is expand from volume V2 to V3. See here, V2 to V3 in the adiabatic expansion. When the temperature drop from T2 to, that is the T3. Here temperature decreases and it from, that is the T2 to T3, and it is denoted by curve BC. VIOC that is shown in the, that is graph, that is 2 to 3 means, that is the 2 means B point and 3 means, that is the C point. So that is denoted by curve BC. Since this step is adiabatic, this step is adiabatic, that is adiabatic here, Q is equal to 0. If W2 is the work done, then according to first law of thermodynamics, that is we have to put Q is equal to 0 in the first law equation. So what is first law of equation? That is Q is equal to delta E plus W, or delta E is equal to Q minus W. We have to transfer that, that is a W on this side. So delta E is equal to Q minus W. Now put, that is Q as 0 in this equation. In this equation, we denote work in this process as W2. So delta E is equal to this minus this, Q is 0 because process is adiabatic. So in adiabatic process, that is heat absorb is, that is constant. It can be taken as 0. Therefore, delta E is equal to Q minus W. Therefore, delta E is equal to put Q as 0. That is the, and instead of W, we can take, that is the W2. We denote the work in adiabatic expansion as W2. So delta E is equal to minus W2. And now rearrange this equation. W2 is equal to minus delta E. W2 is equal to minus delta E. But the value of, that is delta E is CV into T1 minus T2. Delta E is equal to CV into T1 minus T2. Therefore, W2 is put this value of, that is delta E in above equation. What we get, that is W2 is equal to, this minus is there. So we multiply this minus in the bracket term, that is minus T1 and plus T2. So I have written plus T2 first. So this CV as it is. This CV as it is. What remains in bracket? T2 minus T1. So how we, here T1 minus T2 is there, but we have multiplied this minus sign to this bracket. So this T1 becomes minus and T2 becomes so plus, and plus quantity we have taken the first. Therefore, W2 is equal to CV into T2 minus T1. So this is equation number 2. So this is the work done in adiabatic expansion. That is the second step. Now third step. Now third step is isothermal, that is the compression. We also obtain the work done in isothermal. Now see the diagram. So this is the third step. This is first isothermal expansion. This is second adiabatic expansion. This is one means A, 2 means B, there 3 is the C, and 4 is the, that is the D, and this is the isothermal, that is compression. That can be denoted by curve CD. 3 to 4 means, that is here 3 is the C and 4 is the D, CD. So now the cylinder is placed in contact with a heat reservoir at a lower temperature T1. The volume of the gas is compressed isothermally from V3 to V4. The compression takes place and volume of the gas is then compressed isothermally from V3 to V4, and that can be represented by curve CD. I have shown that is curve CD, or 3 to 4 points. Now, during compression, the gas produced heat which is transferred to the low temperature reservoir. Since process takes place isothermally, process takes place isothermally. That is, your delta, the process takes place at constant temperature, and that is delta E. The value of delta E in isothermal process is 0. Therefore, delta E is equal to 0. If Q1 is the heat to the reservoir and W3 the work done on the gas, that is work done in isothermal compression, we have denoted by that is the W3. Then again, that is we have that is minus Q1. Minus Q1 is equal to minus W3, and that is equal to RT1 ln V3 upon V4. And this is the equation number 3. This is work done in isothermal compression. Work done in isothermal compression. That is the third step. Now, last step, that is the adiabatic compression. If you see the diagram, that is this is the last step, adiabatic compression. 4 to 1. 4 to 1. Or we denote this 4 means D, and this 1 means that is the A. DA or 4 to 1. Now, in adiabatic compression, the gas with volume V4 and temperature T1 at D, at point D, we have shown in the graph, is compressed adiabatically, represented by DA curve. We have seen the how it is represented until it regain the original state. What is the original state? Original state is A. So the DA means it regains to its original state. That is, the volume of the stream becomes V1. Initial volume is V1. That is, it regains to original state, and at original state the volume is V1. Temperature T2. The work done W4 in this step is given as, so the work done in adiabatic compression is given as minus W4 is equal to minus CV into T2 minus T1. This is equation number 4. So in equation 1, 2, 3, 4, we have obtained work done in each step. That is work done in isothermal expansion, work done in, that is adiabatic expansion, then work done in isothermal compression, and lastly 4th, that is work done in adiabatic, that is compression. We call that equation as that is 1, 2, 3, and 4. Now the total work done W, the total work done W in Carnot cycle is obtained by adding all these 4 equations. We have, that is, we have 4 equations. What is first equation? If you see here, that is the first equation, work done in isothermal expansion. So this is the W1. Second, that is W2, work done in adiabatic expansion. This we denote by equation number 2. Then isothermal compression, this we have denoted, that is the by equation number 3. And lastly, that is a adiabatic compression, work done in adiabatic compression, we have denoted by, that is the W4. Now total work done, that is the W, is obtained by adding all these 4 equations. Therefore W is equal to W1 plus W2 plus W3 plus W4. Now therefore put the values of equation 1, 2, 3, and 4 in this equation. So therefore W is equal to W1 first. What is the value of W1? So here is the value of W1, this RT2 ln V2 upon V1. So put that value, that is RT2 ln V2 upon V1 plus W2. So what is the value of W2 here? W2, that is CV into T2 minus T1. Put this value, that is W2, CV into, that is T2 minus T1 plus, that is the, here is the W3. W3 is the minus W3. I have taken here minus W. This is the value of minus Q1. So, and it is equal to work. So minus W3, and the value of minus W3 is RT1 ln V4 upon V3. So I have taken that is RT1 ln V4 upon V3. Now here is the minus W4. Minus W4. And what is the value of minus W4? This is the value of minus W4, minus CV T2 minus T1. So we have put values of W1, W2, W3 and W4. Now solve this equation. Then see here, that is here is the plus term CV into T2 minus T1, and here minus CV T2 minus T1. So this get cancel here. This get cancel here. So that is the this CV T2 minus T1 and this minus CV T2 minus C1. This get cancelled. What remains then? Therefore, W is equal to this remains R T2 ln V2 upon V1. So I have written that is R T2 ln V2 upon V1. So this CV and this CV get cancelled. Plus this is plus and this is minus. Plus this RT1 ln V4 upon V3. See here, that is RT1 ln V4 upon V3. Or we can write this W is equal to RT2 ln V2 upon V1 as it is. Now ln of V4 upon V3. So we have to change this. That is, we have to write V3 upon V4. Then what we have to do here? We have to take the minus sign. Understand? Here is the plus. So V4 upon V3. Remember, see here, that is important here. So here is the plus. So we have taken V4 upon V3. But we have to write V3 upon V4. So what we have to do? Here we have to take minus. That is log M minus log N is equal to log of M upon N. This formula is used here. So we can take here minus RT1 ln V3 upon V4. So we call this equation as equation number 5. Now, but for adiabatic expansion and compression, we have that is CV is equal to, we have to remember that equation. We have taken from thermodynamic concepts, that is CV is equal to ln T2 upon T1 is equal to R ln V2 upon V3. This is from for adiabatic expansion and compression. We have that is CV ln T2 upon T1 is equal to R into ln V2 upon V3. All this equation number 6. And CV is into ln T2 upon T1 is equal to R ln V1 upon V4. V1 upon V4. Equation number 7. Now observe these two equations. Equation 6 and 7. So what is common here? S, can you hear me? आवाज आ रहा है ना?
Yes, sir.
Yes, sir.
T2 by
See equation
T1.
6 and 7. Equation 6 and 7. So left hand side of equation 6 and 7 are same. That is CV ln T2 T1. And here also CV ln T2 C1. So left hand sides are equal. So right hand side also equal. So these equal and these right hand sides are equal. So we can write. So this R ln also common. So we can cancel here. So what remains? Only this is same. This R and ln same. So they get cancelled. So what remains only? V2 upon V3. See here. This is same. This R ln common. So it get cancelled. V2 upon V3. So this is the V2 upon V3 is equal to this V1 upon V4. So we have see comparing and rearranging equation 6 and 7. I have written directly. That is this get cancelled CV ln T2 upon T1 and CV ln T2 upon T1 on left hand side. This get cancelled. Now these two are also same. So we have also cancelled this R and ln. We cannot cancel this V2, V3 and V1, V4 because they are different. So V3 upon V4, V2 upon V3 is equal to V1 upon V4. Now again rearranging this. Now why we are rearranging? Because we have in equation 5 what we have? V3 upon V4. See here. So for that we have we are getting that is rearranging such that is we have to obtain V3 upon V4. The value of that is the V3 upon V4. So in equation 5, see what is equation 5? W is equal to total work done in Carnot cycle R T2 ln V2 upon V1 minus R T1 ln V3 upon V4. And we have to rearrange in such a way that we have to obtain that is we get that is the V3 upon V4. So in this we can get our V3 upon V4 is equal to V2 upon V1. So we have to put this, that is what is the value of V3 upon V4, that is V2 upon V1. यानी इक्वेशन 5 में देखिए, इक्वेशन 5 में क्या करना है आपको, यहाँ पर V3 अपॉन V2 है इक्वेशन 5 में, V3 अपॉन V4, लेकिन इक्वेशन अभी हमने रीअरेंज इस तरह से किया है कि दैट इज वी कैन गेट V3 अपॉन V4 किसके बराबर है, V2 अपॉन V1 के. सी हियर that V3 upon V4 is equal to V2 upon V1. Then equation 5 becomes, what equation 5? This equation 5, RT2 ln V2 upon V1 minus RT1 ln, instead of this V3 upon V4, what we have to write? Yes, क्या लिखना पड़ेगा आपको यहाँ पे V3 upon V4 के बजाय, नेक्स्ट स्लाइड में जो है दैट इज दिस वन, V3 अपॉन V4 किसके बराबर है, V2 अपॉन V1. तो यहां पर हम लिखेंगे दैट इज V3 अपॉन V4 के बजाय लिखेंगे आप V2 अपॉन V4, दैट इज गिवन बाय हियर, दैट इज दिस. सो then equation 5 becomes, I have written directly, see here, this is equation 5, this is equation 5, RT2 ln V2 upon V1 minus RT1 ln V2 upon V1. So what is the common if we take here instead of V3 upon V4? कॉमन क्या होगा इसमें, यहां पर देखिए इक्वेशन 5 में सिर्फ आपको यहाँ पे V3 अपॉन V4 के बजाय V2 अपॉन V1 रखना है. कॉमन क्या रहेगा, सी इसमें कॉमन क्या है, R कॉमन है, R इज कॉमन. ओके, सो वी हैव रिटन R कॉमन हियर, या R लिखे हमने. ओके, नेक्स्ट अगेन what is common here, ln V2 upon V1, ln V2 upon V1, और यहां पर भी V2 upon V1 ही आएगा, बिकॉज यहां पर जो है देखिए V3 upon V4 is equal to V2 upon V4. So again that is the ln V2 upon V1 is also common, R is common, ln V2 upon V1 is also common. So what remains in the bracket, see here, that is R we have taken common, this ln V2 of V1 we have also taken the, what remains, that is R
minus T1.
ln V2 upon V1 is common, so we can, this T2 remains here, T2, R is R we have to taken common, ln V2 upon V1 also taken common, minus here R we have to take common, and V3 upon V4, that is instead of this V3 upon V4 we have to take put V2 upon V1, so V2 upon V1 is also taken common. So what remains, T1. Therefore what is the final equation, W is equal to R into T2 minus T1 ln of V2 upon V1, and this is equation number 8, and this is the final equation, that is the total work done in Carnot cycle. This is the final equation, that W is equal to R into T2 minus T1 ln of V2 upon, that is the V1. So this is the final equation, that is the total work done in Carnot cycle. So in this way we have obtained, that is total work done in Carnot cycle. So I will repeat in short, that is a Carnot cycle work in 4 steps. First is the isothermal expansion, and we have, that is obtain work done in this step, that is the isothermal expansion, and that we call this work as equation number 1. Now we have obtained, that is work done in adiabatic expansion, second step, that is W2, and we call this as equation number 2. In isothermal compression, again we have to obtain work done in isothermal compression, that is denoted by W3, we call this equation 3. And lastly, that is we have obtained work done in adiabatic compression, that is W4, and we call this equation number 4. Now the total work done is obtained by adding all these work done, that is W is equal to W1 plus W2 plus W3 plus W4. And finally, that is for adiabatic expansion and compression, we have, that is we comparing and rearrange equation 6 and 7, we get V3 upon V4 is equal to V2 upon V1. And finally, equation 5 becomes, that is W is equal to R into T2 minus T1 ln V2 upon V1. So 10 mark question is asked on this, that is bit very important, that is obtain total work done in Carnot cycle. So we have to draw a diagram also and all these 4 steps, and lastly that is total work done, W is equal to W1 plus W2 plus W3 plus W4, and lastly the final equation W is equal to R into T2 minus T1 into ln of V2 upon V1. So this is the total work done in Carnot cycle. Understand? Okay, now next and very important, that is the Carnot theorem. We see in the next period, but I will only introduce that is the Carnot theorem. There are two Carnot's theorem, Carnot first theorem and Carnot second theorem. Carnot. So these are very important. Always in the examination, one theorem is asked. State and prove Carnot first theorem, or state and prove Carnot second theorem. So we will be discuss this Carnot theorem in the next period. Okay. If any difficulty is there, then ask or write in the chat box. Yes, है क्या difficulty है क्या कुछ? इस लेक्चर की लिंक कब मिलेगी? आपको उसके वीडियो लेक्चर की यूट्यूब की लिंक भी चाहिए क्या? यस, यहाँ पे आया हुआ है मैसेज. ओके, आई विल सेंड यू. I will first upload this video. Yesterday I have uploaded video, and today also upload the video and send the link to WhatsApp group. Okay.
Okay, sir.
Okay, thank you. We'll stop here.